So let's create one class called test set. So this one I have created. So what is happening here, let's write one main method. Okay, so before getting into that, let's try to understand set interface. So test set interface is extending another interface, that is collection, and a lot of methods are there. So like how to add the element into the set, and how to check the size, checking that is empty, contains, iterator, remove, add all. Okay, so these are the few methods which are available in set. Okay, so I will tell you about hash set and tree set here. Okay, so let's create one hash set. So I will create the variable of set and say hash set equal to new hash set. So if you see here, I can use any constructor. There are 4 constructors available here. If it is default constructor, the capacity, the initial capacity is 16 and the load factor is 0.75. Okay, so what does it mean? Initial capacity is 16 and load factor 0.75. So when I say initial capacity is 16, so when I create a new object, it will create space for 16 objects in the Java memory. And when 75% of 16 of that 16 objects, 75% of the space that is occupied by 16 objects, when that is filled, it will create another, it will just double that capacity again. Okay, so because it is other than array, this is also growable, so it will create based on the load factor, it will create the another set of space into that Java memory. So that is a place where initial capacity and load factor comes into picture. So when you, as I told you in the case of list, that initial capacity is 10 by default. You can provide your own initial capacity. In case of hash map, there is initial capacity as well as load factor. So load factor, the default load factor is 0.75 and capacity is 16. So 0.75 means 175% of the initial capacity, initial space occupied by this object in the Java memory, when that is filled, it will just double that space. Okay, so that is the place where you need initial capacity and load factor. So load factor is generally we provide less than 1. 1 means 100%. Okay, and that's how you will use these 2 parameters. So let's use it by default one, so that is new hash set. Okay, so hash set and set, those are available in the util package. As I said, most of the collections are available in the util package. So let's try to first add the element. I will add the element using add. Okay, so here when I say add, it will return true or false. Okay, so if I add, say, my name Shiv, if I try to do sys out of this, it should give me true, because there is no duplicate so far. I have added, there is no element I have added here, so it should give me true. So let's, if I add another one, okay, let's try to do another add. So second time it should give me false. So from here you can see that shed doesn't allow duplicate. Here I am trying to add shoe again, that is duplicate, so it should not allow. So who decides the duplicate? Okay, who decides the duplicate? Your equal method, your equals method decides it is equal or it is duplicate. When it is equal, it is duplicate. So because I'm doing the operation on a string, so it should call when you are trying to insert string objects, okay, one after another one, it will call strings equal method, okay, and it will see that it is equal or not. If it is equal, it means it is duplicate. Okay, so if I add Shiv1 here, it will give me true. So it means that I have added two objects, those are unique. Okay, so this is how you can see that set doesn't allow duplicate. Okay, it is not, it will not give you any compile time problem, but it will give you, it will not allow you to it will just ignore the second addition if it is duplicate item. Okay, it will not give you any problem as such, any exception, runtime or compile time, but it will not allow you. Not allow means it will just ignore that. Okay, so let's try to add few more. Let's add, say, Amit, and let's add Naveen. Okay, so because all are unique value, so adding, while adding, it will give you the result of true. Okay, let's try to print our collection, that is hash set. So if you see here, this set you can see, okay, here because we are using the string class, so it will call internally two string, and based on the two string, it will, because two string will return the value of that string, so it will print in the string form. If you are using custom object, it will give you the address of that. Okay, instead of direct values, it will give you address. Okay, so you can try out for the integer and big integer and other data types. Fine, so let's see how you can iterate it. So to get the value, first of all we can check that size. You can print the size. Okay, you can get the value. How you can get the value from the set? So set, you have to iterate the values from set. So if when you say contains will give you a boolean value if you have some value over there or not, okay, in that collection. So if you print it, it should give me the value true, because this value set contains this value. So it should give me true. If I try to give something which is not available in this collection, it should give me false. So that's why you can check the values inside the hash set. Okay, now how to iterate the set? So hash set has iterator. So iterator is, as we have seen in list, we can use that iterator. Iterator of string class, because we want to iterate collection that has a string. Okay, so what we will do, while it dot hash next print it dot next. Okay, in that way you will be able to see all the content of your collection. See here, this is not ordered. First I inserted Shiv, then I Amit, then Naveen, but when I see the output, it is in different way, in different order. So set doesn't maintain the order. Okay, so this is about hash set. How you can sort the value in hash set. Sometimes people will ask this question, how to sort your hash values in the hash set. The good way to sort the values in a hash set, so instead of using hash set you can use tree set. So same example, I will comment it, and same thing I will do using tree set. Okay, so tree set is another class which provides you sorted collection. So if you run this here, you should be getting the sorted value. So that is Amit, Naveen and Shiv. Fine. So here you can do this. Here you can use the tree set. Tree set is required when you do the sorting on set. Okay, suppose you want to store the objects into a collection in the sorted way, then you have to use sorted this tree set. Okay, otherwise if you are using some collection, some array list, you have to manually call the collection dot sort. Okay, here sorting is happening because a string is implementing the comparable. Okay, so let's try to use, instead of a string, let's try to use in tree set. I'm commenting this one also, creating another set. So let's create tree set of employee. Okay, so here I'm adding new employee. I'm providing ID 1 as name Shiv. Okay, and second element, let's add only 4. So if I have say Amit, sorry, let's have 2 duplicate Amit and Naveen. Okay, so here I will iterate. Iterator should be of employee type. Okay, let's see how it works. What it says, it says that com.training Java basic employee cannot cast to java.lang.comparable. Okay, because here I am using tree set. Tree set provides sorting mechanism, so it has to be have employee class has to implement comparable. So let's right now not use tree set, let's use hash set for as of now. Okay, first one is added, second one is also added. Why did not say that it is duplicate? while second because I'm giving same thing. So who, as I said, who decides a duplicate? In case of a string, it overrides equals based on its value of the string. In case of employee, let's see I have any equals method or not. I don't have any equal method. So what I need to override equals method. I need to write my own equals method here. Okay, so in equal method I am writing in such a way that I will just the other object I will convert into employee, and they say that two employees will be equal if their employee dot id equal to this dot id. So if two employee has same id, it means that they are equal. Okay, so employee id equal this id, then only they are equal. Okay, so same time let's override the hash code also. So hash code will be override hash code. It will return int value. So let's return employee id, sorry, this id, and few some identifier, say 2 power 4 or something, 8, some unique hash code. Okay, now let's try to add it, because here when I'm doing the second addition, then it gave me false, because first employee of id of first employee and second employee, it is all false. So all the employees having the same id, so their equal is. So if you when I printed this collection, it has only one, that is its id. Okay, so here if you see, it is printing 1 and Shiv. It means that in the employee class there must be something to string that I might have already implemented. Okay, I have overridden to string. If I don't override this method, let's comment it. If I run this one, it should not give me the 1 and Shiv. It is giving the address of reference of that object. Okay, so so this is what your object will be printed in the collection. So you should always override the string to get the value in the meaningful format. Fine. So I'm back to the good position. So let's try to understand second one. Hash contains Shiv is coming false, because it is, I need to contain the object of employee. So I should say, if I have something like this, if I print it, I should be getting true, because with this object I have the value. When it has contains method, it is internally calling the equal method. If you see here, contains, so this is the class which, this is the method which is declared in the set interface, and we want to see the declaration of sorry, how this contains is implemented in hash set. So let's go to hash set. Okay, so here contains is map dot contains key. Okay, so if you drill down this method is having entry and all those things. You need to understand the data structure in very much detail. So for a very much high level, you can see that it will call your equals method. If you want, you can go to your equals method and put one breakpoint and then debug it. So once you debug it, you see that the flow comes here, okay, to compare. This is the one shoe, and this employee, the current employee, this is again one shoe. So this will try to compare it, the ID, and say it is equal. That's reason it says that it contains. Okay, so it is calling because every time when you are adding, it will check, because it has to check for uh, it is already existing or not, so it will keep on adding it. Okay, so here in case of hash set, it is having duplicate objects. Okay, so your duplicate objects are just getting overridden, just getting overwritten. So this object is overwriting this one, this object is overwriting this one. So because they are okay, so what is happening here, in case when you are adding the first object, it is one shoe, while adding the second one, it will check for duplicate. If it is duplicate, it will not allow you to add it. So that's the reason you are just ended up with adding first value, because all other values are having the ID same, so that's the reason those are duplicate. And set does not allow duplicate. So let's try to add another IDs. So in case of employee, multiple employee can have the same name. Now if you see, all the elements have been added: 1 Shiv, 2 Shiv, 3 Amit, and 4 Naveen. So once I iterate it, I will get all the values here, and those are not duplicate because their IDs are different. So whenever you are writing your custom classes, you need to override this equals and hash code to perform well when you are trying to add them into collection. Okay, so let's try to use now tree set, because I want to sort it. Okay, so if you run it, because this class does not implement comparable, so it will throw me exception, because tree is meant for sorting the objects available in the collection. So what I need to do, I need to implement comparable, implements comparable. So, and I want to compare only employee objects. Okay, because I have implemented comparable, so I have to implement unimplemented method, that is compare to. Okay, so I will compare to method I am going to implement. What is compare to? So it says that return. So on what basis I will compare? I will compare based on their ID basis. You can compare with their name, you can sort with their name, you can sort with their ID. So let's try to sort with their name. So return this dot name, that is string. String has compare method. Okay, compare to let's use ignore case, o dot name. Okay, so if two names are same, it means that their compare will be 0. Okay, they will return 0. So in this way I can sort them. Okay, let's try to store first. So they have been stored, and they have been stored in sorted way. Okay, so here I did not provide any sorting here. So tree set does the sorting based on the how your compare to logic has been written. Here compare to logic is based on the name, so that's reason it is getting the sorted order of Amit, Naveen and Shiv. Okay,